Welcome to Unit 8. This is 8.1, Intro to Circles and Tangents. First, let's start with some definition. A circle is just the set of all points in a plane that are equidistant from a given point called the center. A radius is the distance from the center to any point on the circle. Congruent circles are just circles that have the same radius. The diameter is the distance across the circle through its center. So it's two radius put together, creating a straight line. So here's what these words kind of look like. So we got the center, which is point P. We have a radius, which is from P to the edge of the circle. And then the diameter goes from one edge of the circle to the other through the center. A couple more definitions we need to go over is a chord. Chord is a segment whose endpoints are points on a circle, meaning here, this is a chord. Now, a diameter is a type of chord. It's a special chord that goes through the center. So not all chords have to go through the center. Okay. The next one is a secant. It's a line that intersects a circle in 2 points. The idea is it is a chord that extends past the circle. You got a tangent. A tangent is a line that touches the circle in exactly 1 point. Okay, so ST is a tangent. So let's look at some examples on this. AH, that is a tangent. EI is a diameter, it goes through the center. DF does not go through the center, so it's just a chord. And CE is a radius, it's half the diameter. Some more definitions. We got tangent circles. Tangent circles intersect at 1 point. So here's what tangent circles look like. We have concentric circles, which are coplanar circles that have the same center, but obviously don't intersect. Then we have common tangents. These are a line or segment that is tangent to 2 coplanar circles. You can have internal tangents, and you can have external tangents. So internal tangents are segments that join between the 2 circles, and external tangents intersect the circles outside of the circles. So here is a type of internal. Notice it goes between the 2 circles, and here is an external, touching outside of the circles. Okay, so tell whether the common tangents are internal or external. So the first one, A, those are internal, they're between the 2 circles. B is external because they're outside of the circles. Get some more definitions in here. So you got the interior of circle, which are points that are inside the circle, and you got exterior of the circle, which are outside the circle. That kind of goes along with the tangents. The point of tangency, the point at which a tangent line intersects the circle. So the point of tangency is the point in which the circle meets the tangent. Alright, here's one of our theorems. We're going to add this to our cheat sheet. So if a line is tangent to a circle, then it is perpendicular to the radius. So here we got a tangent. The point of tangency is P. PI is our tangent. So our angle IPQ or QPI is right, because it's perpendicular. The converse of that is if it's perpendicular, if it forms a 90-degree angle, then the line is tangent. So that's how we know if their line is tangent to or circle. So our example of this is EC a tangent. Well, to check, we have to use Pythagorean theorem, because Pythagorean theorem will tell us if it is a right triangle. So we do 11 squared plus 43 squared, and we're going to see if it's equal to 45 squared. We get 121 plus 1,849, and we get 2,025. Combine our like terms, and we get 1970 and 225, which that doesn't work. So it is not tangent. Okay, so you just check to see if Pythagorean theorem works. All right, our next theorem we're going to add to our cheat sheet, congruent tangent segments theorem. The idea is that if you have 2 tangents, then the distance from the point of tangencies to the point of intersection is congruent. So the idea is that RS is congruent to TS. So here, our example, we have 2 tangents. we're going to set these equal. X squared plus 2 equals 11. And then we subtract 2 and we get 9. Take the square root, we find that x is 3 or negative 3. That's it for the notes. Good luck on the practice.